Settle in. Pull your blanket a little tighter. Let your shoulders drop away from your ears. Because what you're about to hear over the next few hours is going to do something unusual to your mind. It's going to fill it so completely with wonder, with warmth, with the most breathtaking facts about the planets that surround us in this solar system, that every other thought, every worry, every to-do list, every anxious replay of the day simply won't have room to exist anymore. That's the secret, you see. The universe is so impossibly, so outrageously, so tenderly vast, that your problems, my problems, all of our problems become gossamer thin in comparison. Not in a dismissive way. Not in a your life doesn't matter way. Quite the opposite. The planets are going to show you exactly how precious and rare and miraculous your existence is. And somehow, knowing that, really feeling it, is one of the most relaxing things a human mind can experience. Now, before we drift into the cosmos together, here is your one shocking revelation to begin with. Are you ready? You have never, not once in your entire life, been still. Not even right now, lying in your bed, eyes heavy, body sinking into the mattress. At this very moment, you are moving at approximately 67,000 miles per hour. That is the speed at which Earth orbits the Sun. You are also spinning because Earth rotates at roughly 1,000 miles per hour at the equator. And the entire solar system itself is orbiting the center of the Milky Way at about 514,000 miles per hour. And the Milky Way is moving through the universe at somewhere around 1.3 million miles per hour. You, in your bed, perfectly still, are the fastest moving thing you have ever personally experienced. And somehow, none of that motion disturbs a single strand of your hair. The universe holds you so gently, so perfectly, that all of that extraordinary speed feels like absolute stillness. If that isn't the most soothing thought you've encountered today, just wait. We are only 3 minutes in. Before we go further, if this kind of slow, wonder-filled, planetary journey is something that helps you sleep, helps you relax, helps your mind find that beautiful, quiet place, please hit like on this video. It genuinely helps more people find it when they need it most, at 2 a.m., at 3 a.m., in that restless place where the mind won't slow down. Subscribe if you haven't already, because we make these long, careful, deeply researched sleep journeys regularly, and I would love for you to be here every time. And I want to ask you something. Drop it in the comments before you drift off. Or maybe tomorrow morning when you wake up. What country are you watching from? And what time is it where you are right now? Because right now, all over the world, people are lying in their beds listening to these exact words. And there is something almost magical about that. Someone in New Zealand, someone in Brazil, someone in Norway where the winter nights are impossibly long, someone in Japan. We are all at this moment looking up at the same solar system together. I find that deeply comforting. I hope you do too. Now, let's begin at the beginning. Let's begin with the ground beneath your feet, and then lift gently, gently, off into the dark and the stars. You know, Earth, of course. You've lived on it your entire life. You know its seasons, its weather, its oceans. But I wonder if you've ever been introduced to Earth the way a planetary scientist would introduce it, as a living, breathing, almost impossibly lucky world that shouldn't, by any reasonable cosmic calculation, exist the way it does. Let me introduce you to Earth as if you were meeting it for the first time. Earth is the 5th largest planet in our solar system. It has a diameter of about 7,917 miles. It is, as far as we know with absolute certainty, the only world in the universe that currently hosts life. Not probably, not maybe, with certainty. Every living thing we have ever confirmed, every bacterium, every blue whale, every sleeping person listening to this right now, lives on this one world. This small, blue, and probably lucky world. Think of it like this. Imagine the entire observable universe. All 93 billion light years of it is the Pacific Ocean. Earth's biosphere, the thin shell of life on this planet, is less than a single drop of water from that ocean. One drop. And in that one drop is every story ever told, every song ever sung, every love ever felt, every civilization ever built. That's where you are right now, in that drop. Now here is where it gets soothing in a very specific way. Earth has been doing this, holding life, keeping it safe, nurturing it, for approximately 3.8 billion years. A geologist named Andrew Knoll at Harvard University has spent his career studying the earliest evidence of life on Earth, tracing it back through ancient rocks to those first, tiny, brave cells that figured out how to exist. 3.8 billion years of continuity, of life persisting, of the planet maintaining just exactly the right conditions for living things to thrive. What that means for you personally is this. Every single ancestor you have, going back through every generation, every parent and grandparent and great-grandparent going back millions and billions of generations all the way to that first living cell, every single one of them survived. Every one of them lived long enough to have a child. There is an unbroken chain of survival stretching 3.8 billion years directly to you, lying in your bed tonight. You are the current endpoint of the longest winning streak in the history of this planet. Let that sit for a moment. Let your body feel that. You are not fragile. You are the product of billions of years of extraordinary resilience. Now, Earth has a feature that is so ordinary to us that we almost never think about it, but which planetary scientists consider one of the most extraordinary things in the known solar system. Earth has a large moon. Not just any moon, a remarkably large moon relative to the size of the planet. Our moon is about 1/4 the diameter of Earth, which makes it the largest moon relative to its planet in the entire solar system, with the exception of Pluto's moon Charon, though Pluto is no longer classified as a planet. Why does this matter? Because that moon is stabilizing you as you sleep. Here is what I mean. Earth's axial tilt, the angle at which Earth leans as it orbits the sun, is about 23.5 degrees. That tilt is what gives us seasons. Without it, there would be no spring, no summer, no autumn, no winter. The tilt distributes sunlight across the planet and makes Earth climatically stable over long periods of time. And that tilt is held steady, remarkably steady over millions of years by the gravitational influence of the moon. Without the moon, Earth's tilt would wobble chaotically, shifting perhaps for nearly 0 degrees, which would make the poles receive almost no sunlight, to as much as 85 degrees, which would tip the planet nearly on its side and create climate swings so dramatic that complex life might never have evolved. Jacques Lasker, an astronomer at the Paris Observatory, modeled this in the early 1990s and showed that without the moon, Earth's axis could have varied by as much as 85 degrees over millions of years. The moon, that gentle silver light that has watched over humanity since before we had words for it, is a climate stabilizer, a cosmic anchor. It holds Earth steady so that life can persist and evolve in stable enough conditions to produce, eventually, you. So when you see the moon from your window, or when you imagine it rising above whatever clouds might be overhead tonight, know that it is doing its quiet, loyal work, holding Earth still, keeping the seasons turning in their steady rhythm, making sure that the planet remains the kind of place where living things can sleep peacefully through the night. Think of it like this. The moon is like a hand on a spinning top, not stopping the spin, but keeping it from tumbling over into chaos. A gentle gravitational steadiness. Applied for billions of years, Earth also has a magnetic field. This might seem like a dry physics class sort of fact, but I want you to feel what it means, because it is genuinely protective and gentle in the most cosmic sense. Deep inside Earth, far below the crust you live on, below the mantle, down in the outer core, liquid iron is flowing, slowly, constantly, churning in enormous convection currents, driven by Earth's internal heat. And this flowing liquid iron generates a magnetic field that extends out from Earth in all directions, surrounding the planet in an invisible cocoon that reaches tens of thousands of miles into space. This magnetic field, called the magnetosphere, deflects the solar wind, that constant stream of charged particles that the sun blasts outward in every direction. Without the magnetosphere, those particles would strip away Earth's atmosphere over millions of years, the way they appear to have stripped away Mars's atmosphere long ago. With it, Earth's atmosphere is protected, held in place, kept thick and warm and breathable. There's one more Earth fact before we leave our homeworld and begin traveling outward through the solar system. And this one, I promise you, is a genuine mind-blown moment. If you were to compress all of Earth's history, all 4.5 billion years in it, into a single 24-hour day, beginning at midnight and ending at the current moment, human civilization would appear in approximately the last 1 to 2 seconds. Agriculture, writing, cities, science, art, music, philosophy, everything that we think of as human culture and achievement, it all fits into the final heartbeat of Earth's long day. And yet, and here's the part that I find inexplicably comforting, those last 1 to 2 seconds have also contained everything you love. Every piece of music that has ever moved you. Every book that changed how you see the world. Every person who has made your life feel worth living. All of it, all of the warmth and meaning and beauty of human experience, happened in that final moment of Earth's long, quiet story. We are new. We are brief. And we are somehow breathtaking. Sleep on that for a moment. Because next, we are going to leave Earth behind and drift toward our closest planetary neighbor. And what we find there is going to change how you think about both beauty and tragedy. Let me take you to Venus. Venus is Earth's nearest planetary neighbor. It is almost exactly the same size as Earth minus 95% of Earth's diameter, 80% of Earth's mass. For a long time, early astronomers imagined Venus as a twin of Earth, hidden beneath its perpetual cloud cover. They wrote stories about jungles on Venus, oceans on Venus, perhaps even life on Venus. Carl Sagan himself, in his early career, considered the possibility of Venusian life before better data arrived. The reality of Venus is one of the most dramatic stories in the solar system, and surprisingly, one of the most soothing when you understand its lessons. Venus is the hottest planet in our solar system. Not Mercury, which is closest to the Sun. Venus. The surface temperature on Venus is approximately 900 degrees Fahrenheit, or 465 degrees Celsius. Hot enough to melt lead. Hot enough to melt tin. Hot enough that a spacecraft landing on Venus will be destroyed within about an hour, as the Soviet Venera probes discovered between the 1970s and 1980s in a series of extraordinarily brave missions. Those probes, launched from Earth, traveling millions of miles, landing on a world of crushing pressure and furnace heat, managed to send back images and data for between 23 minutes and about 2 hours before succumbing to the environment. The reason for Venus's extreme heat is a runaway greenhouse effect. Venus's atmosphere is about 96% carbon dioxide, with an atmospheric pressure at the surface roughly 92 times greater than Earth's at sea level. Imagine being 3,000 feet underwater in the ocean. That is approximately the pressure on the surface of Venus. Thick atmosphere traps solar heat so effectively that the planet cannot cool itself. The heat simply builds and builds. Now here is the mind-blown moment. Venus and Earth started in very similar positions. They formed from similar materials. They are similar sizes. They orbit relatively close to each other in the solar habitable zone. At some point in their early histories, both planets may have had liquid water oceans. Venus may once have been habitable. A study published in 2019 by researchers at NASA's Goddard Institute for Space Studies, including Michael Way and Anthony Del Genio, modeled early Venus and suggested that it may have had a shallow liquid water ocean and habitable temperatures for up to 3 billion years, longer than complex life has existed on Earth. 3 billion years of potential habitability, wiped out by a slow-moving climate catastrophe as the sun gradually brightened and the Venusian greenhouse effect took hold. Venus is a cautionary tale, but it is also, in the most profound sense, a love letter to Earth, because everything that makes Earth terrible at being Venus, its lower atmospheric density, its liquid water that absorbs and moderates heat, its magnetic field, its plate tectonics which cycle carbon through the planet and regulate the atmosphere. All of those things that could have been otherwise, that were not guaranteed to work out the way they did, all of them worked out. For you, for all of us. Think of it like this. Imagine two paths in a forest. Both paths look similar at the start. One leads to a meadow full of flowers and soft light where you can rest. The other leads, slowly, over millions of years, into an inferno. Earth took one path. Venus took the other. And you get to sleep in the meadow tonight because Earth happened to take the right turn. There is something else about Venus that I find quietly beautiful, even in its tragedy. Venus rotates very slowly, and more intriguingly, backward relative to most planets in the solar system. If you could stand on Venus and watch the sky, which you cannot, for the reasons we just discussed, the sun would rise in the west and set in the east. A Venusian day, the time it takes Venus to complete one rotation on its axis, is actually longer than a Venusian year. It takes Venus 243 Earth days to rotate once, but only 225 Earth days to orbit the sun. A day on Venus lasts longer than its year. That means if you lived on Venus, in some impossible science fiction, heat-proof bubble, and you watched the sun rise, the planet would have already completed an entire orbit around the sun before the sun finished its slow arc across the sky and set. There is something almost dreamlike about that. A world where a single day contains an entire year, where time moves to a completely different rhythm than anything we experience on Earth. The solar system, it turns out, is full of these different temporal rhythms, these alien clocks, all ticking at their own pace alongside our own familiar 24-hour cycle, which brings us beautifully, gently, to the next planet outward from the sun, a world that is in some ways the opposite of Venus. Cold where Venus is hot, thin atmosphered where Venus is thick, ancient and dusty, and quiet in a way that makes the heart both ache and wonder. We are going to Mars next, and I promise you what I'm going to tell you about. Mars will make you see the night sky differently for the rest of your life. Mars. Even the name carries a kind of weight, doesn't it? Mars, the red planet. The planet that has captured human imagination more than any other. The planet that has been the setting for more science fiction stories, more dreams of exploration, more debates about the possibility of life beyond Earth than any world in our solar system other than Earth itself. And yet the real Mars, the actual Mars, as we know it now from decades of orbiters and landers and rovers, is somehow more fascinating than any of the fictional versions. Because the real Mars tells a story of a world that had everything and lost it, slowly, quietly, over billions of years. Let me paint you a picture of Mars as it might have looked about 3 to 4 billion years ago. Imagine a planet slightly smaller than Earth, about half Earth's diameter, with a thicker atmosphere than it has today, with liquid water flowing across its surface. The evidence for this is now beyond serious scientific dispute. The Mars Reconnaissance Orbiter, which has been mapping Mars from orbit since 2006, has revealed ancient river valleys, lake beds, deltas where rivers once met standing bodies of water, and mineral deposits that only form in the presence of liquid water. John Grotzinger, who led the science team for the Curiosity rover mission at NASA's Jet Propulsion Laboratory, described ancient Gale Crater, where Curiosity landed, as a habitable environment that once contained a freshwater lake that persisted for potentially millions of years. Millions of years. A lake on Mars, sitting quietly, reflecting a younger, slightly cooler sun, perhaps with chemistry that could have supported microbial life. And then something changed. Mars is smaller than Earth. Its interior cooled faster. And when its interior cooled, its magnetic field, generated by that same liquid iron core mechanism that protects Earth, faded. Without a magnetic field, the solar wind began to erode the Martian atmosphere. Slowly, steadily, over hundreds of millions of years, the atmosphere thinned. As it thinned, it could no longer trap enough heat to keep water liquid. Temperatures dropped. The water froze, or was driven underground, or was lost to space as the atmosphere continued to thin. Today, Mars's atmosphere is about 100 times thinner than Earth's. The surface pressure is roughly equivalent to being at 100,000 feet altitude on Earth, 3 times higher than commercial aircraft fly. Liquid water cannot exist on the surface under those conditions. Any liquid water exposed to the Martian atmosphere would either freeze instantly or boil away, not because Mars is warm enough to boil water, but because the atmospheric pressure is so low that water's boiling point drops below its freezing point. Water on Mars's surface would simultaneously freeze and boil away in a process called sublimation. The lakes are gone. The rivers are gone. What remains are the empty valleys and the ancient lake beds, like the bones of a world that once dreamed of becoming something more. Here is the mind-blown moment I promised you about Mars, and it is one that I have never stopped thinking about since I first encountered it. Mars has the largest volcano in the entire solar system, Olympus Mons. It is approximately 374 miles across at its base, roughly the size of the state of Arizona, and about 16 miles high. That's nearly 3 times the height of Mount Everest. If you were standing on the slopes of Olympus Mons, the volcano would be so large that the curvature of Mars would prevent you from seeing its edges. You would not know you are on a volcano at all. You would just see a vast, gently sloping plain stretching to the horizon, and beyond the horizon in every direction, for hundreds of miles. The caldera at its summit, the volcanic crater at the top, is about 50 miles wide and nearly 2 miles deep. It is an almost incomprehensible structure. And yet Olympus Mons fell not through violent, cataclysmic eruptions, but through slow, patient, millions of years accumulation. Lava flowing, building, layer by layer, like a work of extraordinary patience. A planet constructing its own monument through geological time. Think of it like this. Olympus Mons is like a sandcastle built not in an afternoon on a beach, but grain by grain, over millions of years, by a world working quietly and patiently in the dark. And when it was done, what it had built was the tallest mountain in the solar system. Sometimes the most magnificent things take the longest, most patient processes. I find that deeply soothing. The idea that patience, over enough time, can build something that dwarfs everything you thought possible. Mars also has Valles Marineris, a canyon system that stretches about 2,500 miles across the Martian surface. To put that in perspective, the Grand Canyon is about 277 miles long. Valles Marineris is 9 times longer, and in places nearly 7 miles deep. If you placed Valles Marineris on a map of the United States, it would stretch from New York City to Los Angeles. And here is what makes Valles Marineris special in the context of this sleepy journey through the planets. It formed not through water erosion, as the Grand Canyon did, but primarily through tectonic stress, the Martian crust splitting apart as magma moved beneath it and created the enormous bulge of the Tharsis Volcanic Plateau. It is a scar on Mars that tells the story of the planet's own internal struggles, its geology working to release pressure and reshape itself. Every planet, it seems, carries its scars. And like all scars, they become part of what makes the landscape beautiful. Mars, for all its tragedy, the lost water, the faded magnetic field, the emptied atmosphere, is a breathtaking world. The sunsets on Mars are blue. Because of the way fine Martian dust scatters light, the sky at midday is pinkish, and the sunsets glow a cool, ethereal blue, the exact opposite of Earth's golden and orange sunsets, blue Martian sunsets. Somewhere 140 million miles away on average, the sun is setting every evening over those empty canyons and ancient lake beds, and the sky turns the color of the deepest, most peaceful twilight you can imagine. I find that beautiful almost beyond words. No, we have visited Earth, Venus, and Mars. We have stayed in the inner solar system, in the rocky, intimate neighborhood near the sun. But as we move outward, past the asteroid belt, out toward the cold and the dark, the solar system becomes something else entirely, something wilder, something almost incomprehensibly large, something that I think you are going to love. Stay with me. The next place we're going is the largest planet in the solar system, a world so big that all the other planets could fit inside it with room to spare. A world of eternal storms and mysterious depths and moons, more interesting than the planet itself. We are going to Jupiter. Jupiter. Let's start with the size, because the size of Jupiter has to be felt rather than simply stated. If Earth were the size of a grape, Jupiter would be the size of a basketball. Jupiter is 11 times wider than Earth. You could fit 1,321 Earths inside Jupiter's volume. Its mass is 2.5 times greater than all the other planets in the solar system combined. It is not just the largest planet in our solar system. It is, by a significant margin, the dominant planet. The gravitational presence of Jupiter shapes the entire architecture of the solar system in ways that we are only beginning to fully understand. Here is the mind-blown moment about Jupiter that I want you to hold in your mind as you drift toward sleep. Jupiter may be the reason you exist. This is not poetic license. This is planetary science. Jupiter's enormous gravity acts as a kind of shield for the inner solar system. When comets and asteroids, the debris left over from the formation of the solar system, traveling in long elliptical orbits, venture into the inner solar system, they often encounter Jupiter's gravitational field first. Jupiter either captures these objects, they become trapped in orbit, or crash into Jupiter, slingshoots them out of the solar system entirely, or deflects them into orbits that keep them away from the inner planets. Without Jupiter acting as this gravitational guardian, the rate of large impacts on Earth would be dramatically higher. We would be hit by large comets and asteroids much more frequently. And those impacts, when they are large enough, can cause mass extinctions. The impact that killed the non-avian dinosaurs 66 million years ago, for instance, was caused by an object about 6 miles wide. Imagine that happening not once every 100 million years, but several times more frequently. Life might still have evolved on Earth without Jupiter's protection. But whether it would have had the uninterrupted time it needed to produce complex creatures, vertebrates, mammals, primates, humans, that is much less certain. Kevin Grazier, a planetary scientist who spent years working on the Cassini mission to Saturn, has studied Jupiter's role as a solar system guardian extensively. His research and modeling suggest that while Jupiter does deflect some objects toward Earth, it's not a perfectly benign shield. On balance, it keeps the inner solar system more stable than it would be without Jupiter's massive presence. The biggest planet in the solar system has been quietly looking out for the smaller ones for 4.5 billion years. There is something in that image, that enormous, ancient world keeping watch over the smaller, more fragile planets closer to the sun, that I find profoundly calming. Think of it like this. Jupiter is like a big, quiet protector standing at the edge of the neighborhood, not doing anything dramatic, not calling attention to itself, but by its mere presence, making everything inside a little safer. Jupiter's most famous feature is the Great Red Spot, a storm that has been raging continuously for at least 350 years and possibly much longer. It was first clearly documented by Giovanni Cassini in the 1660s, though some historians believe it may have been observed even earlier. 350 years of continuous storm. A single weather event lasting longer than the entire history of the United States. Longer than the telescope has existed. longer than the modern world has existed. The Great Red Spot is about 1.3 times the width of Earth. If you put Earth inside the Great Red Spot, it would fit with room to spare. Winds at the edges of the storm reach about 400 miles per hour. The storm rotates counterclockwise, completing a full rotation every 7 days or so. And here is what I find strangely beautiful about the Great Red Spot. It is shrinking. Over the 150 or so years that we have been observing it carefully, it has gone from roughly 25,000 miles wide to about 10,000 miles wide today. It is getting smaller. The longest-running storm in the solar system is very gradually winding down. Scientists are not entirely sure why, or whether it will eventually disappear entirely. There is something almost meditative about that. A storm that has been raging for centuries, slowly quieting, as if even the most powerful forces, given enough time, find their way to stillness. But Jupiter's moons, Jupiter's moons are where this really gets extraordinary. Jupiter has 95 known moons. 95? The 4 largest, Io, Europa, Ganymede, and Callisto, were discovered by Galileo Galilei in January 1610, and they were the first objects in the solar system observed to orbit something other than Earth or the Sun. Galileo called them Medicean stars to honor his patrons, but they are now known as the Galilean moons. When Galileo observed them night after night and watched their positions change relative to Jupiter, it provided some of the earliest direct observational evidence that not everything in the universe orbits Earth. The universe was bigger than anyone had imagined. Objects moved in ways that didn't center on us. That discovery, those 4 tiny points of light moving around Jupiter, began to shift how humanity understood its place in the cosmos. One of the most important intellectual revolutions in human history started with a man pointing a telescope at Jupiter on a January night in Italy and watching small lights move. Of these 4 moons, Europa is the one that has captured the imagination of planetary scientists more than almost any object in the solar system. Europa is slightly smaller than Earth's moon. Its surface is covered in ice, smooth, white, cracked ice that looks from space like a giant cracked eggshell. And beneath that ice, beneath a shell of ice that may be anywhere from a few miles to tens of miles thick, Europa has a liquid water ocean. A liquid water ocean on a moon of Jupiter, hundreds of millions of miles from Earth. The ocean beneath Europa's ice is estimated to contain twice as much liquid water as all of Earth's oceans combined. It exists because of tidal heating, the gravitational tug of Jupiter, constantly stretching and squeezing Europa as it orbits, generating heat through friction in the moon's interior, keeping the water liquid despite the extreme cold of the outer solar system. And where there is liquid water and heat, on Earth at least, there is almost always life. NASA is planning a mission called Europa Clipper, which launched in October 2024 to study Europa in detail. Scientists, including astrobiologist Chris McKay, have spent careers thinking about what life in Europa's ocean might look like, probably microbial, probably living near hydrothermal vents on the ocean floor, probably never knowing that above them is 20 miles of ice, and above that ice is a solar system. And in that solar system is a small blue planet where beings with telescopes are lying in their beds, dreaming about finding it. If there is life in Europa's ocean, it has never seen a star. It has never known daylight. It has spent its entire existence in the deep dark of an alien ocean floor, warmed by the tidal embrace of the largest planet in the solar system. And we might find it within our lifetimes. I want you to hold that image before we move on. Somewhere, perhaps, in the dark ocean beneath Europa's ice, something lives. Something that has never known a sky. And here you are, above a sky, in a world full of light, on a planet that has been nurturing life for nearly 4 billion years. You are on the lucky side of the ice. Sleep on that for just a moment. Because next, we travel to what many people consider the most beautiful object in the entire solar system. A world so visually extraordinary that when Galileo first saw it through his telescope, he thought he was seeing three separate objects. A planet surrounded by a ring system so vast, so delicate, so perfectly formed, that it seems impossible. Seems like something a universe wouldn't make by accident. We are going to Saturn. There is a story about the astronomer Christian Huygens that I love. In 1655, Huygens was studying Saturn through a telescope he had built himself, trying to make sense of the strange changing shape of the planet, the bumps that Galileo had noticed and puzzled over in 1610. Galileo had called them Saturn's ears. He thought they were companion planets. He wasn't sure. He was confused. Huygens solved the puzzle. He realized that Saturn is surrounded by a ring, a flat, circular disk of material encircling the planet like a halo. He was so astonished by this discovery that he was afraid to publish it, afraid that no one would believe him. He was essentially claiming that a planet could have an enormous, flat ring floating around it in space, something that had never been imagined, never been predicted by any theory. So he published his discovery initially as an anagram, a scrambled string of letters that he could later unscramble to prove he had made the discovery first, once he'd gathered more evidence. The anagram, when unscrambled, reads in Latin, "It is surrounded by a thin flat ring, nowhere touching, and inclined to the ecliptic." He knew. He was certain. But the universe had shown him something so extraordinary that he needed to be careful about how he told the world. I find that story deeply human and deeply moving. The universe reveals something breathtaking, and the first human response is wonder so intense it becomes a kind of caution, a need to be sure, to earn the announcement, to be worthy of the revelation. Saturn's rings are one of the most spectacular structures in the solar system. They extend for about 4,000 miles above Saturn's equator out to nearly 200,000 miles from the planet, a span wider than the distance from Earth to the Moon, stretched out as an enormous flat disk. And yet, they are extraordinarily thin. The main rings are, on average, only about 30 feet to 60 feet thick. In some places possibly as thin as a single story of a building. Think of it like this. If you made a scale model of Saturn's rings using a piece of paper, standard notebook paper, about 0.004 inches thick, that paper would need to be about half a mile wide to represent the thinness to width ratio of Saturn's rings. A piece of paper half a mile across, impossibly thin. The rings are made primarily of water ice, tiny particles ranging from the size of a grain of sand to the size of a house. Each particle is in its own individual orbit around Saturn, following the laws of gravity with perfect precision, never colliding violently, never clumping together into a moon, just drifting in their cold, bright, silent orbit. Billions and billions of ice particles, each one a tiny reflector of sunlight, each one adding to the collective shimmer that makes Saturn's rings visible from Earth through even a modest telescope. When you look at Saturn through a telescope, and I strongly encourage this if you ever have the opportunity, because it is one of the most reliably astonishing experiences a person can have. It looks fake. It looks like a sticker, like a planet with a plastic ring pushed onto it as a prop. The brain simply does not have a category for a planet that looks like that. It violates some deep expectation about what a real thing is supposed to look like. The Cassini spacecraft, which orbited Saturn from 2004 until its deliberate plunge into Saturn's atmosphere in 2017, gave us the most detailed view of Saturn and its system ever achieved. Over 13 years of continuous observation, Cassini revealed Saturn's moons, Saturn's atmosphere, Saturn's magnetic field, and Saturn's rings in extraordinary detail. One of the Cassini mission's chief scientists, Carolyn Porco, described the Saturn system as having everything, the most diverse and scientifically rich environment in the solar system outside of Earth itself. Carolyn Porco oversaw the Cassini imaging team and is responsible for some of the most iconic photographs of Saturn ever taken, including an image called "The Day the Earth Smiled," a photograph of Saturn taken from Cassini's position in orbit in which you can see, in the background beyond Saturn's rings, a tiny pale blue dot, Earth, visible from nearly 900 million miles away, tucked between Saturn's rings like a note in a bottle. Porco alerted people on Earth when the photograph would be taken and asked them to look up, wave, smile, to be in the photograph. Millions of people did. We are in that photograph, all of us on that tiny pale blue dot, caught in the distance between Saturn's rings on a summer day in 2013. But perhaps the most astonishing thing about Saturn's rings is how young they are, or rather, how young they might be. For a long time, astronomers assumed Saturn's rings were ancient, as old as the solar system itself, perhaps 4.5 billion years old. But data from Cassini's final orbits, when the spacecraft dove between the planet and its innermost rings, revealed that the rings appear to be much younger. A 2019 study led by Luciano I. Esses of Sapienza University of Rome, using Cassini's measurements of Saturn's gravitational field and the mass and composition of the rings, suggested the rings are only about 100 million years old, possibly younger. In geological and astronomical terms, 100 million years is very recent. Saturn existed for more than 4 billion years before it got its rings. The rings may have formed when a large icy moon or comet wandered too close to Saturn and was torn apart by tidal forces, the same gravitational shredding that creates the Roche limit around every large body. The shredded remains spread into the ring system we see today, which means that when the dinosaurs were alive on Earth, long before humans existed, Saturn had no rings, or had different, smaller, less spectacular rings. The Saturn we see today, with its magnificent ring system, may be a temporary feature of the solar system. In another 100 million years, the rings could be significantly reduced or even gone, as their particles gradually rain down onto Saturn's atmosphere. We are living in the brief, cosmically precious moment when Saturn has its rings. When Saturn looks the way Saturn looks. Think of it like this. Imagine arriving at a spectacular fireworks display exactly when the most beautiful burst illuminates the sky. You didn't plan it, you didn't know, but you arrived at exactly the right moment. Every human who has ever lived, every human alive today, every human who will live for perhaps the next 100 million years, we are all arriving at the fireworks exactly when the sky is lit up. We are the lucky witnesses. Now, let me tell you about Saturn's moon Titan, because Titan is unlike anything else in the solar system, and it fills me with a particular kind of dreamy wonder that I think you are going to love as you drift toward sleep. Titan is Saturn's largest moon and the second largest moon in the solar system. It is bigger than the planet Mercury. It is the only moon in the solar system with a dense atmosphere, so dense that if you stood on Titan's surface, the atmospheric pressure would be about 1.5 times Earth's surface pressure. You could breathe there almost, except the air is mostly nitrogen, not oxygen, and you would still need an oxygen supply. But you wouldn't be crushed. You wouldn't need a pressurized suit. Just warmth and oxygen. Titan has weather. Clouds and rain and rivers and lakes and seas, but not water. On Titan, with temperatures around minus 290 degrees Fahrenheit, water is frozen solid as rock. What flows on Titan, what fills its lakes and rivers and rains from its skies, is methane, liquid methane, natural gas in liquid form. There are seas of liquid methane on Titan. The largest, Kraken Mare, is larger than Earth's Caspian Sea. These methane seas are probably still and dark. Because Titan receives so little sunlight at its great distance from the sun that the energy available to drive waves is minimal. They are likely as smooth as glass, reflecting the distant, tiny, pale sun. The Huygens probe, released from the Cassini spacecraft and descended through Titan's atmosphere on January 14, 2005, transmitted data for about 72 minutes on the surface before its battery died. It is the most distant landing ever achieved by a human spacecraft from Earth. And what it found was a world of extraordinary alien beauty. Rounded pebbles of water ice, shaped as if by flowing liquid. A flat, foggy landscape. An orange sky. Somewhere, beneath an orange sky, on the shore of a glassy methane sea, Huygens sat and listened and sent its signal home, and then went quiet. I think about Huygens sitting there sometimes, silently, on that alien shore, as if it went to sleep in a new world and simply never woke up, ready to travel deeper into the outer solar system? Because our next stop is a planet so unusual, so sideways, so perfectly strange, that it seems designed to make physicists scratch their heads. A planet that rotates on its side. A planet where each pole gets 42 years of continuous sunlight, followed by 42 years of continuous darkness. A planet that is blue-green and cold and magnificent and deeply weird. Uranus is next. Uranus is the planet that got the strangest origin story in the solar system. And I mean that quite literally. Long ago, somewhere between 3 and 4 billion years ago, in the early, chaotic period of solar system formation, something enormous hit Uranus. We're talking about an object possibly as large as Earth, maybe larger. And it hit Uranus with enough force and at the right angle to tip the planet over onto its side. Uranus now rotates with its axis tilted at about 98 degrees relative to its orbit around the Sun. For comparison, Earth's tilt is 23.5 degrees. Uranus is tipped past horizontal. It essentially rolls around the Sun on its side, like a ball being rolled down a hallway, rather than spinning upright like a top. The consequences of this are extraordinary. At Uranus's poles, you experience something no other planet in the solar system offers in quite this way. The South Pole points almost directly at the Sun for about 42 years, one Uranian summer. During that time, the pole receives continuous sunlight for 4 decades. The Sun doesn't rise and set. It just circles in the sky, never setting, for 42 years. Then comes winter and 42 years of complete, absolute darkness. A child born at the beginning of a Uranian polar summer would be 42 years old before they saw their first polar sunset. And then they would spend the next 42 years in permanent night. Think of it like this. Imagine living your entire childhood, your teenage years, your early adulthood, your middle age, all of it in continuous daylight, the sun never setting, never dipping below the horizon. And then, one day, the sun sets, and it doesn't rise again until you are in your 80s. Uranus keeps its own time, follows its own strange, beautiful logic. And that tipped, peculiar sideways existence makes it one of the most unique worlds in our solar system. Uranus is an ice giant. Unlike Jupiter and Saturn, which are gas giants composed primarily of hydrogen and helium, Uranus, and its outer neighbor Neptune, is composed largely of ices, water, methane, ammonia, in a hot, dense fluid form under enormous pressure deep within the planet. The term ice here is somewhat misleading, because at the pressures deep inside Uranus, these compounds exist not as frozen solids, but as dense, hot fluids. But the term has stuck. The characteristic blue-green color of Uranus comes from methane in its upper atmosphere, which absorbs red light and reflects blue and green light back into space. It is a cool, serene color, the color of deep water, the color of glaciers, the color of something very cold and very still. Uranus has 27 known moons, and unlike most moons in the solar system, which are named for gods and mythological figures, Uranus's moons are named after characters from the works of William Shakespeare and Alexander Pope. Oberon and Titania from A Midsummer Night's Dream, Ariel from The Tempest, Miranda, also from The Tempest, Caliban from The Tempest, Prospero, Sycorax, Puck. The moons of Uranus are a Shakespeare collection, drifting in the cold dark of the outer solar system. carrying names from some of the most beautiful literature ever written. Oberon and Titania, the fairy king and queen of A Midsummer Night's Dream, orbiting a sideways planet billions of miles from the theater where those names were first spoken. I find that beautiful beyond what I can easily articulate. The words of Shakespeare carried into space on the names of distant moons. Literature and astronomy woven together in the outer solar system. Here is a mind-blown moment about Uranus that is rarely discussed. Despite being closer to the Sun than Neptune, Uranus is actually colder. Neptune's effective temperature is around -200 degrees Celsius. Uranus, though it should be slightly warmer based on its distance from the Sun, registers at approximately -224 degrees Celsius, making it the coldest planetary atmosphere in the solar system. Colder than Neptune. Colder than Pluto's surroundings. The reason appears to be that Uranus, unlike every other planet in the solar system, emits almost no heat of its own. Jupiter, Saturn, and Neptune all radiate more heat than they receive from the Sun. They have internal heat sources from their formation that still warm them billions of years later. Uranus does not. Or if it does, that heat is somehow trapped and not escaping to space. One leading theory connects this to that ancient collision that tipped Uranus sideways. The impact may have caused Uranus to release most of its primordial heat into space very quickly, leaving it with no significant internal heat source today. The collision that changed the planet's orientation may have also drained it of its warmth. Uranus is the coldest planet in the solar system, possibly because of an ancient wound that it carried for billions of years. Tipped over by an enormous impact and left a little colder for it. There is something quietly melancholy and somehow deeply relatable about that. We should keep moving. We have one more planet to visit in our tour of the 8 worlds of the solar system. The furthest planet from the Sun, the windiest planet in the solar system. The planet with a storm that makes Jupiter's great red spot look small. A world of deep azure blue and supersonic winds and strange moons, sitting at the very edge of our planetary family. Neptune waits. Neptune is the most distant planet in our solar system. At an average distance of about 2.8 billion miles from the Sun, 30 times further from the Sun than Earth, Neptune receives only 1/900th of the sunlight that Earth does. From Neptune's surface, if you could stand there, the Sun would appear not as the blazing disk we know from Earth, but as a very bright star. Still the brightest object in the sky by far, but clearly a star, not a disk. A point of intense, cold light. Neptune is 17 times the mass of Earth, and about 4 times Earth's diameter. Like Uranus, it is an ice giant. It is a rich, deep blue, deeper than Uranus's blue-green, caused by methane in its atmosphere absorbing red light and an additional, not yet fully understood, atmospheric component that enhances the blue even further. It is one of the most beautiful colors in the solar system. Neptune was discovered on September 23, 1846, and its discovery is one of the most extraordinary achievements in the history of science, because Neptune was found not by looking, but by calculating. Astronomers had noticed that Uranus was not orbiting quite where Newton's laws predicted it should be. Something was pulling on it slightly, perturbing its orbit in ways that could only be explained if there was another large planet further out, exerting a gravitational tug. 2 mathematicians, John Couch-Adams in England and Urbain Leverrier in France, independently performed the calculations to predict where that unknown planet should be. Leverrier communicated his predictions to the Berlin Observatory, and on the very first night that astronomer Johann Gottfried Galle pointed his telescope at the predicted position, there was Neptune, within 1 degree of where Leverrier said it would be. A planet predicted by mathematics before it was seen by human eyes. The solar system had written the answer in the orbital wobble of Uranus, and mathematics read it out. Think of it like this. Imagine someone telling you that if you go outside, walk exactly 500 steps north, turn east, and look straight up, There will be a star in a precise location that has never been mapped. And you go and you look, and the star is there. That is what Adams and Leverrier did, except instead of 500 steps north, it was 2.8 billion miles into the outer solar system. Mathematics is how we see things too far away for eyes to find on their own. Neptune is the windiest planet in the solar system. Despite being so far from the sun, so cold, so dark, receiving such little solar energy, Neptune has winds that reach 1,300 miles per hour, nearly twice the speed of sound on Earth, the fastest winds ever directly measured in the solar system. The source of these winds is not completely understood. At Neptune's distance from the sun, solar energy alone should not be able to drive winds this intense. There must be internal heat from Neptune's formation, contributing to atmospheric dynamics, and indeed, unlike Uranus, Neptune does emit significantly more heat than it receives from the sun. That internal warmth is what drives the extraordinary atmospheric activity. When the Voyager 2 spacecraft flew past Neptune in August 1989, the only spacecraft to ever visit Neptune, and it still has not been revisited, it photographed a storm on Neptune called the Great Dark Spot. At the time, this storm was comparable in size to Earth. It rotated counterclockwise and had the highest wind speeds of any atmospheric feature measured in the solar system at that time. When the Hubble Space Telescope turned to look at Neptune after Voyager 2's flyby, the Great Dark Spot was gone. It had vanished sometime in the early 1990s. Unlike Jupiter's Great Red Spot, which has persisted for centuries, Neptune's dark spots appear and disappear over years to decades. Neptune is dynamic in a different way than Jupiter, more changeable, more restless. New dark spots have appeared and disappeared on Neptune in the years since. A world of storms that form and dissolve. At the edge of our solar system, in the cold and the dark and the wind, Neptune has 16 known moons. The largest, Triton, is one of the most geologically active objects in the outer solar system, and also one of the strangest. Triton orbits Neptune in the wrong direction. Every other large moon in the solar system orbits its planet in the same direction the planet rotates. They formed from the same rotating disk of material and inherited the same rotational momentum. Triton orbits Neptune in the opposite direction. Retrograde orbit, scientists call it. This almost certainly means that Triton did not form with Neptune. It was captured, a world that formed elsewhere in the outer solar system, perhaps in the Kuiper Belt, and was captured by Neptune's gravity at some point in the distant past. The gravitational interaction of that capture heated Triton dramatically, keeping its interior warm for potentially billions of years. Triton is slowly spiraling inward toward Neptune. In about 3.6 billion years, long after the sun expands into a red giant and transforms the inner solar system, Triton will cross Neptune's Roche limit and be torn apart by tidal forces. It will become a ring system, much as Saturn's rings may have formed. Neptune will gain rings from the destruction of its own captured moon, but that is 3.6 billion years away. Tonight, Triton is still whole, still orbiting Neptune in its backwards, retrograde path, still geologically active, with nitrogen geysers erupting from its surface, sending plumes of gas 5 miles into the thin Triton sky. Geysers, on a moon 2.8 billion miles from the sun, in the dark, at minus 235 degrees Celsius, one of the coldest surfaces in the solar system, still geologically alive enough to push geysers of nitrogen into space. Before we leave Neptune and begin moving into the deepest, most philosophical parts of our journey, I want to give you something to hold as you drift toward sleep. Voyager 2, the spacecraft that visited Neptune in 1989, is still traveling. Right now, as you lie in your bed, Voyager 2 is more than 12 billion miles from Earth, traveling at about 34,000 miles per hour through interstellar space, the space between the stars. It has left the solar system behind. It crossed the heliopause, the boundary where the sun's solar wind ends and interstellar space begins, in November 2018. It is the only human-made object other than Voyager 1 to have reached interstellar space. On board Voyager 2 is a gold-plated audiovisual disc, the Voyager Golden Record, containing sounds and images selected to portray the diversity of life and culture on Earth, in case the spacecraft is ever found by another civilization. The sounds on the record include music from many cultures, greetings in 55 languages, and sounds of Earth: rain, wind, waves, animals, a human heartbeat. Somewhere 12 billion miles away, drifting silently through interstellar space, there is a golden record carrying the sound of rain, the sound of wind, the sound of a human heartbeat. Voyager 2 will take about 40,000 years to reach even the vicinity of another star. It may drift through the galaxy for billions of years without ever being found. Or it may someday be picked up by hands that don't look like ours. Opened, played, the sounds of Earth echoing in some place we cannot imagine. That thought, that somewhere in the dark our message is traveling, is one of the most profoundly lonely and beautiful things I know. And somehow, it makes me feel anything but alone. We have now visited all 8 planets, but we are not done, not even close. Because there is a place beyond Neptune, a region of small worlds and ancient ice and possible undiscovered planets, that is the edge of our solar family. And beyond that edge, there is something that will reframe everything we've discussed tonight. But first, we should talk about what home feels like from a distance. Because one photograph, taken on February 14, 1990, from 3.7 billion miles away, changed how humanity sees itself. And it is one of the most important things I will tell you tonight. On February 14, 1990, the Voyager 1 spacecraft had been traveling away from Earth for nearly 13 years. It had already visited Jupiter, Saturn, and their moons. Now it was far beyond the planets, heading into the outer solar system and eventually into interstellar space. At the urging of Carl Sagan, NASA turned Voyager 1's camera back toward the Sun and the inner solar system one final time before the camera would be powered down forever. The camera took a mosaic of photographs of the solar system from its distant vantage point. And in one of those photographs, a photograph of a beam of sunlight scattered in the camera's optics, there is a tiny pale blue dot. That dot is Earth. From 3.7 billion miles away, our entire world, all 7,917 miles of its diameter, all 8 billion people who would eventually live on it, all its oceans and mountains and cities and history, fits into less than a single pixel, a pale blue mote of dust suspended in a sunbeam. Carl Sagan wrote about this photograph in his 1994 book. His words have been quoted so many times that they have become something close to secular scripture for millions of people. I won't quote him directly. His words are his own, and deeply worth reading in their original form. But the essence of what he expressed was this: every human being who has ever lived, lived on that dot. Every king and peasant, every act of kindness and cruelty, every love affair and war, every religion and civilization, every moment of joy and suffering in human history, concentrated onto a mote of dust in the vast cosmic dark. That image, the pale blue dot, is one of the most important photographs ever taken. Not because of its technical achievement, though that is extraordinary, but because of what it makes us feel, because of the perspective it offers. From out there, our planet looks small. From out there, our differences look smaller still. From out there, we are not Americans or Indians or Brazilians or Norwegians or Japanese. We are Earthlings, sharing a fraction of a pixel in the dark. I want to linger here for a moment, because I think this is where the planetary facts we have been collecting all night begin to settle into something more than information. They become a framework, a way of seeing. You have traveled with me in the last few hours, from Earth to Venus to Mars to Jupiter to Saturn to Uranus to Neptune, and to the edges of our solar system. You have met the winds and the storms and the moons and the magnetic fields and the ancient craters and the sideways planets and the geysers and the golden records. You have seen the solar system as it is, not as a diagram in a textbook, but as a family of worlds, each one extraordinary in its own way, each one shaped by billions of years of physics and chemistry and gravity working their slow, patient, beautiful processes. And now I want to ask you, where are you in that picture? Not philosophically, literally. You are on the pale blue dot. You are part of Earth's biosphere, that thin shell of life on a medium-sized rocky planet, orbiting a medium-sized star in the outer arm of a medium-sized spiral galaxy, among hundreds of billions of galaxies in a universe that has been expanding for 13.8 billion years. And here is what I find most soothing about that reality, and it is something that took me a long time to fully feel rather than just understand. You did not create any of this. You did not design the solar system. You did not arrange the planets in their orbits, or calibrate the sun's energy output, or position Jupiter in exactly the right place to deflect comets, or give Earth its magnetic field, or tilt the moon to stabilize the seasons. You did not do any of it. The universe did it. Physics and chemistry and time and gravity did it. And yet, here you are, breathing inside it. The universe has been building toward your existence for 13.8 billion years. Not in any mystical or design sense, necessarily, but in the purely physical sense that every particle in your body was forged in the heart of a star that lived and died before the sun existed. The calcium in your bones was made inside a dying star. The iron in your blood was forged in a supernova explosion. The oxygen you are breathing right now was produced by billions of years of photosynthesis, by plants that evolved on a planet stabilized by a moon and protected by a magnetic field and shielded by Jupiter. You are not separate from the cosmos. You are the cosmos in one of its current temporary forms, looking at itself. Carl Sagan used to say that we are a way for the cosmos to know itself. The universe has no eyes, but you do. The universe cannot feel wonder, but you can. When you look up at the night sky and feel that particular ache of smallness and largeness at the same time, that is the universe experiencing itself through you. That thought, more than almost anything else I know, makes me feel peaceful. We are not halfway through our journey yet. Ahead of us are the deep mysteries, the outer solar system, the nature of time on other worlds, the deep philosophical questions that the planets open up when we look at them long enough. And there is one final section that will bring everything together in a way I hope will leave you feeling not just relaxed, but genuinely changed. But for now, just rest in this. You are on the pale blue dot. You are warm. You are breathing. The planets are in their orbits, doing what they have always done. The moon is holding Earth's axis steady. Jupiter is standing watch at the edge of the inner solar system. Saturn's rings are catching sunlight, briefly beautiful in their few 100 million years of existence. Voyager is carrying the sound of rain into the dark between the stars. Everything is exactly where it is supposed to be. So are you. Let us talk about time. Not the abstract philosophical concept of time, but the very specific, very concrete experience of time as it differs from planet to planet. Because if you have ever felt like time was moving too fast, or too slow, or felt like a day wasn't long enough, or felt like a year took forever, well, the planets have some perspective to offer you. A day is defined by how long it takes a planet to rotate once on its axis. A year is defined by how long it takes a planet to complete one orbit around the sun. Every planet has both of these measurements, and they are all delightfully, strangely, wonderfully different. On Mercury, the closest planet to the sun, a day, one complete rotation, takes 58.6 Earth days. A year, one complete orbit, takes 88 Earth days. So a Mercurian year contains only about 1.5 Mercurian days. If you lived on Mercury, you would experience 1.5 days per year. Your birthday would come around almost twice per day. The relationship between Mercury's day and year is actually locked in a 3-to-2 orbital resonance for every 2 orbits Mercury makes around the Sun. It rotates exactly 3 times. This resonance was stabilized by the Sun's gravity long ago, and Mercury has been spinning at this precise rate ever since. The Sun's gravity and Mercury's rotation have found their perfect equilibrium, and they have maintained it for billions of years. Think of it like this. Mercury's day and year are like 2 gears of different sizes that have been turning together for so long that they are perfectly worn into each other's teeth. Each rotation and each orbit fitting together with a mathematical precision that would be impossible to plan, but emerges naturally from physics over billions of years. On the other end of the spectrum, a year on Neptune, 1 complete orbit around the Sun, takes 165 Earth years. Neptune was discovered in 1846. It completed its first full orbit since discovery in 2011, 165 years later. No human being who was alive when Neptune was discovered lived to see Neptune complete a single orbit. The planet moves so slowly in our sky that tracking it requires either a telescope or extraordinary patience. If you were born on Neptune and lived what felt to you like a normal human lifespan of 80 Neptune years, 80 complete orbits of Neptune around the Sun, you would have lived for 80 times 165 Earth years, 13,200 Earth years. From the perspective of a Neptunian year, human civilization, all of agriculture, writing, cities, empires, science, technology, has existed for less than 1 Neptune year. The Sumerians invented writing less than 1 Neptune year ago. The construction of the pyramids happened less than 1 Neptune year ago. The entirety of recorded human history fits inside a single Neptunian year. I find this simultaneously humbling and comforting. The universe operates on timescales that make our longest recorded histories feel like a single breath. And yet, within that single breath, we have built and loved and discovered and created so much. We have made so much of our brief time. Here is something genuinely mind-bending about time and the planets that involves both physics and our everyday experience. Time passes at slightly different rates depending on your gravitational environment. This is not a metaphor or a poetic device. It is a measured, confirmed, experimentally verified consequence of Einstein's general theory of relativity. First published in 1915, the stronger the gravitational field, the slower time passes relative to a weaker gravitational field. This effect is so real and so significant that the GPS satellites orbiting Earth, which are in a weaker gravitational field than the surface, must have their clocks corrected for the fact that time passes slightly faster for them than for us on the ground. Without that correction, GPS systems would accumulate errors of about 38 microseconds per day, which would translate to positional errors of about 7 miles per day. Your phone's GPS works because engineers account for Einstein's relativity in the satellite clocks. Now apply this to Jupiter. Jupiter's gravity at its cloud tops is about 2.5 times Earth's surface gravity. This means that time, very slightly, passes slower at Jupiter's cloud level than it does here on Earth. Not by much. We are talking fractions of a second over millions of years. But it means that if you could somehow spend a year hovering in Jupiter's upper atmosphere, when you return to Earth, you would be very, very slightly younger in an absolute physical sense than if you had spent that year on Earth. The mass of these planets doesn't just dominate gravitationally, they shape space-time itself. They dent the fabric of the universe simply by existing. And the universe bends around them, and time bends with it. You live on a planet that dents the fabric of space-time. You are walking on a gravitational depression in the universe. And every heartbeat you have, every breath, happens in slightly slower time than it would if you were floating in space, far from any mass. You are, in the most literal physical sense, time traveling compared to the empty void of space. moving through time at Earth's specific gravitational rate. A rate that is neither the fastest possible in the solar system nor the slowest. Just Earth's particular, familiar human pace. And speaking of pace, here is something I want you to hold as your eyelids grow heavy. There is no universal clock. There is no metronome ticking away somewhere that defines the correct rate of time. Different places in the universe experience time differently, as we have discussed. Different planets have different days and different years. Different gravitational fields bend time at different rates. What this means is that your experience of time, your sense of a day passing, of a year unfolding, of a life being lived, is completely specific to where you are, to Earth's rotation and orbit and gravity. It is yours. It belongs to Earth and to you. The 24-hour day was not given to you by an arbitrary human decision. It was given to you by Earth's rotation, by the specific angular momentum that Earth has carried since the moon-forming impact 4.5 billion years ago. The early Earth rotated faster. A day was only about 6 hours long when Earth was very young, but the moon's tidal friction has been gradually slowing Earth's rotation, and the day has grown from 6 hours to 24 hours over billions of years, and it will continue to slow. In the far future, Earth's day and the length of the month will equalize, and Earth and the moon will become tidally locked, as our moon is already tidally locked to Earth, always showing us the same face. For now, you have 24 hours. That's what physics has given you. The days are neither too long nor too short. They are exactly what billions of years of gravitational evolution between Earth and its moon have produced. Your schedule, in a cosmic sense, was set by the moon. I hope that thought is making you feel sleepy. Because next, and I mean this is one of the most beautiful sections of our whole journey tonight. We are going to talk about what lies beyond the planets, the edge of the solar system, and what that edge tells us about our place in the galaxy. Beyond Neptune, there is a region of the solar system called the Kuiper Belt, a broad band of icy objects extending from Neptune's orbit out to about 50 times Earth's distance from the Sun. This is where Pluto lives, along with thousands of other small icy worlds called Kuiper Belt objects. This is the source of many short-period comets, objects that occasionally get nudged inward by gravitational interactions and fall toward the Sun on elliptical orbits. Pluto was discovered in 1930 by a young astronomer named Clyde Tombaugh, working at the Lowell Observatory in Arizona, comparing photographic plates of the night sky, taken at different times and looking for any star that moved between the photographs. Moving stars are not stars. They are objects within our solar system, much closer to us than the true stars. Tombaugh found Pluto on February 18, 1930, and it was classified as the 9th planet for 76 years, until the International Astronomical Union officially reclassified it as a dwarf planet in 2006. Pluto is now understood to be one of the largest Kuiper Belt objects, a world in its own right, but one of many similar worlds in the outer solar system, rather than a uniquely dominant planet like the 8 classical planets. What we know about Pluto comes primarily from the New Horizons spacecraft, which performed the first flyby of Pluto on July 14, 2015, 85 years after Pluto's discovery. New Horizons traveled for 9 years and 3 billion miles to spend just a matter of hours in close proximity to Pluto, collecting as much data as it could at 36,000 miles per hour. The images New Horizons returned were extraordinary. Pluto has mountains made of water ice, rising nearly 20,000 feet, as tall as some of Earth's major mountain ranges. It has a vast, flat, heart-shaped plain called Tombaugh Regio, named for Clyde Tombaugh, covered in nitrogen ice. It has atmospheric hazes, blue and backlit by the distant sun. It has a subsurface ocean, possibly of liquid water, kept liquid by radioactive decay in its core. Clyde Tombaugh died in 1997, before New Horizons was launched. but his ashes were placed on the New Horizons spacecraft. And on July 14, 2015, Clyde Tombaugh's ashes flew past the world he discovered, 3 billion miles from home. I do not know if that is one of the most touching things in the history of space exploration, or the most touching thing in the history of space exploration. I suspect the latter. Beyond the Kuiper Belt, there is one more region of the solar system, and it is one of the most distant, most mysterious, most poetically evocative places in all of astronomy. The Oort cloud. The Oort cloud is a vast spherical shell of icy objects surrounding the entire solar system, not just orbiting in the plane of the planets, but extending in every direction, forming a bubble that reaches from about 2,000 to 100,000 times Earth's distance from the Sun. At its outer edge, the Oort cloud extends roughly a quarter of the way to the nearest star system, Alpha Centauri. The Oort cloud is where long-period comets originate. Comets like Comet Neowise, which delighted skywatchers in 2020, or Hale-Bopp, which dazzled in 1997. These objects spend millions of years in the dark cold of the Oort cloud, in orbits so large that they barely move relative to us on human timescales. Then something, a passing star, a gravitational perturbation, nudges one of them slightly, and it begins the long, long fall inward, millions of years of travel. And then it arrives in the inner solar system, grows a tail of gas and dust as the sun's heat drives material off its surface, and blazes across our sky for a few weeks before retreating back into the deep dark from which it came. The comets we see, those beautiful visitors that appear in our skies and fill us with awe, are travelers from an almost unimaginably distant realm. They have been sleeping in the dark for millions of years, and they make one brief pass through the warmth and the light before retreating back to the edge. Jan Oort, the Dutch astronomer who proposed this cloud's existence in 1950, was working entirely from indirect evidence, the distribution of the orbits of long-period comets, because no telescope has ever directly observed the Oort cloud. It is too distant, its objects too small and too dark, too far from the sun to be illuminated. The Oort cloud exists as a mathematical inference, a prediction that fits all the data we have, but which has never been directly seen. We know it is there. We have never seen it. This is, I think, one of the most profound examples of scientific confidence and humility working together. Confidence to say, based on what we can observe, this must be there. Humility to say, we cannot yet see it. Think of it like this. The Oort cloud is like the deep ocean. Not the coast, not the continental shelf where we have mapped and explored and documented. The true deep ocean, the abyssal plains miles below the surface, where light has never reached. We know the deep ocean exists. We have instruments and models and indirect evidence. We have retrieved a few samples, but we have directly observed only a tiny fraction of it. And yet we do not doubt it. The solar system has its own deep ocean, and we live near the shore. Beyond the Oort cloud, the sun's gravitational influence finally fades enough that objects are no longer bound to the solar system. Beyond that boundary, which may be as far as 100,000 to 200,000 times Earth's distance from the sun, perhaps halfway to the nearest star, we leave our solar family behind entirely and enter the territory of interstellar space. The space between stars. Voyager 1 and Voyager 2 have crossed that threshold. They are now in interstellar space, the first human-made objects to escape the solar system, the first artifacts of Earth's civilization to venture into the space between the stars. They carry our music and our voices and our DNA measurements and the sound of our rain. And they travel in silence at 34,000 miles per hour, which in the scale of interstellar space is almost exactly like standing still. In 40,000 years, Voyager 1 will pass within 1.6 light-years of a star called Gliese 445. In 300,000 years, both Voyagers will still be traveling through the interstellar medium. In 5 billion years, When the sun expands and swallows the inner planets, the voyagers will still be out there, drifting through whatever the galaxy has become. We have sent our message into a future we cannot imagine. And with that, I want to bring you back. Back from the edge of the solar system. Back from the Oort cloud and the interstellar medium. Back toward the sun, toward the inner planets, toward Earth, toward the atmosphere above you right now, toward the ceiling above your bed, toward the pillow beneath your head. Come home with me, because the next thing we need to talk about is what all of this means for you personally. How these planetary facts, these cosmic distances, these ancient timescales, how they connect to your life, your worries, your sense of self. Here is a question I want you to sit with as your breathing slows and your body grows heavy. What if knowing about the planets could actually change how you feel about your problems? Not in a dismissive way. Not in a, your problems are tiny, so they don't matter way, because they do matter. Your challenges matter. Your pain is real. Your worries are legitimate. The planets do not make them go away, but the planets do something else. They change the resolution at which you see your situation. Let me explain. One of the most common experiences of anxiety is what I would call tunnel vision. The feeling that whatever problem you are facing is not just large, but total. That it fills your entire horizon. That there is nothing outside of it. The anxious mind is a mind that has temporarily lost its perspective. Not because it is weak or broken, but because it has become so focused on an immediate threat that it has lost access to the wider view. The planets are a wider view. When you think about Europa's ocean, that dark, warm, alien sea beneath 20 miles of ice, possibly hosting life that has never seen a star, your problems become proportional again. They don't disappear. They become their actual size. They become manageable rather than total. This is not a psychological trick. It is a genuine cognitive recalibration. Awe, and specifically cosmic awe, has been studied by psychologists including Dr. Keltner at the University of California. Barkley, whose research has shown that experiences of awe, moments when we perceive something vastly greater than ourselves, reliably reduce self-referential thinking, increase feelings of connection to others, and create a measurable sense of having more time. Awe, Keltner's research suggests, actually changes the subjective experience of time, making moments feel longer, fuller, richer. The planets create awe, and awe creates peace. Think about the atoms in your body. You are made of approximately 7 trillion atoms. That's a 7 followed by 27 zeros. Every one of those atoms was forged in a stellar process. Hydrogen, the most abundant element in your body, was made in the first few minutes after the Big Bang, 13.8 billion years ago. Carbon, oxygen, nitrogen, the calcium in your bones, the iron in your blood, all forged in the nuclear furnaces of stars that lived and died billions of years ago. Their materials scattered through space in supernova explosions, seeding molecular clouds from which new stars and planets formed, until eventually some of that stardust became the solar nebula from which our sun and planets formed, and some of that planetary material became Earth's crust, and some of Earth's crust became the chemistry of life, and that chemistry became you. Every atom in your body has existed since the first few minutes of the universe, or has been forged in a star. You are approximately 13.8 billion years old, in the sense that your constituent atoms have existed for that long. They have been in nebulas, in stars, in supernova, in molecular clouds, in planetesimals, in Earth's mantle, in oceans, in single-celled organisms, in ancient forests, in dinosaurs, in mammals, in your ancestors, and now they are in you. The iron in your blood right now was once inside a star. That is not a metaphor. That is nuclear astrophysics. You are not a temporary arrangement of matter that appeared from nothing. You are the current form of matter that has been in continuous existence since the universe began. You are part of an unbroken chain of physical existence, stretching back 13.8 billion years. When you feel small, remember that you are also old beyond all imagining. And when you feel insignificant, remember that you are the universe's current method of looking at itself. I want to tell you about an astronaut named Ron Guerin, who spent 5.5 months aboard the International Space Station in 2011. In his memoir, he described looking down at Earth from orbit and experiencing what astronauts have come to call the overview effect, a profound cognitive shift in awareness that occurs when you see Earth from space. Earth without borders. Earth as a single, unified, fragile world floating in the darkness. He wrote that looking down at Earth while orbiting, he could see the atmosphere, the thin blue line at the edge of the planet, barely visible like a film of moisture on a mirror. All the air that every living thing has ever breathed, all the weather that has shaped every civilization, all the sky that every bird has ever flown through. It's all in that thin blue line. It represents less than 1% of Earth's radius. It is almost nothing. It is everything. Many astronauts have described similar experiences. Edgar Mitchell, who walked on the moon during Apollo 14, described a feeling of interconnectedness during his return journey, a sense that the universe was in some way conscious, or at least that his consciousness was inseparable from it. Rusty Schweickart, who performed a spacewalk during Apollo 9, described feeling that he was there for humanity, that he wasn't just one person floating in space, but that every human being who had ever looked up at the sky was in some way present with him. You don't have to go to space to feel some version of this. Right now, in your bed, you can close your eyes and imagine looking down at Earth from orbit, the blue of the oceans, the white of the clouds, the brown and green of the continents, the thin, thin line of the atmosphere, all of it floating in the dark. And somewhere in that blue and green and white, so small you could cover it with a fingertip from that altitude, is the building you're in, is the room you're in, is you. And you are not small. You are the view. You are what the universe looks like when it is experiencing itself from the inside. I want to pause here and do something a little different. If you're still awake, and it's completely all right if you've been drifting in and out, this is a sleep video. Drifting is the entire point. But if some part of you is still listening, I want to invite you to do something simple. Take a breath, a slow one. Let it in and let it out all the way. That oxygen you just breathed was released into Earth's atmosphere by photosynthetic organisms, plants and algae and cyanobacteria over billions of years. Before about 2.4 billion years ago, Earth's atmosphere contained almost no free oxygen. It was the great oxidation event, the slow, patient, billions of years process of photosynthetic life filling the atmosphere with oxygen that made the air you just breathed possible. Every breath is a gift from 2.4 billion years of biological work. You just received a gift from billions of years of planetary history. Feel it for a moment. Let that land wherever it wants to in your body. Good. Now we keep going. Because we are approaching the final movement of our planetary journey, and what lies ahead is the most beautiful, the most mind-bending, the most personally meaningful material of the whole night. The planets move in orbits that are governed by mathematics so precise that we can calculate the position of Neptune 1,000 years from now with extraordinary accuracy. The laws of planetary motion were first described by Johannes Kepler in the early 1600s, derived from painstaking astronomical observations made by Tycho Brahe at his observatory in Denmark. Kepler spent years studying Brahe's data, particularly the precise tracking of Mars's position in the sky over years, trying to find the underlying pattern. The prevailing assumption at the time was that the planets moved in perfect circles, because circles were considered geometrically perfect, and the heavens were presumed to embody geometric perfection. Kepler tried circle after circle, and couldn't make the mathematics work. The data and the theory kept disagreeing. And then, Frustrated and nearly certain he was missing something fundamental, Kepler tried an ellipse, an oval. Not a perfect circle, but a slightly stretched one. And it worked. The data matched. Mars moved in an ellipse with the Sun at one of its two focal points. The orbit was not a perfect circle. It was an imperfect, beautiful, mathematically precise ellipse. Kepler published his first two laws of planetary motion in 1609 and his third in 1619. They state, essentially, that planets orbit in ellipses, that a planet sweeps out equal areas of its orbital ellipse in equal times, meaning it moves faster when closer to the Sun and slower when farther away, and that the square of a planet's orbital period is proportional to the cube of its semi-major axis, the size of its orbit. These are not just convenient approximate rules. They are exact mathematical relationships that hold for every planet, every moon, every asteroid, every comet. They work because they emerge from deeper physics, from Newton's law of universal gravitation, from the mathematics of mass and distance and force. The universe runs on mathematics, and those mathematical relationships are so precise, so consistent, so reliable, that they have held for 4.5 billion years without exception. Every orbit has obeyed these laws since the solar system formed. No planet has ever deviated. No comet has ever forgotten the formula. Think of it like this. The mathematics governing planetary orbits is like a symphony that has been playing without interruption for 4.5 billion years. The same notes, the same relationships, the same structure, faithfully maintained. You and I have only been listening for a few decades. But the music has been playing since before the Earth existed. There is a relationship between the planets that borders on the mystical, not because it is actually mystical, but because mathematics can produce results so elegant that they feel like they were designed. The planets are connected by what are called orbital resonances, gravitational relationships, where the orbital periods of two or more objects are in a simple integer ratio. For instance, for every orbit Neptune completes, Pluto completes exactly 2/3 of an orbit. Their orbits are in a 2-to-3 resonance. This means that Pluto can never come close to Neptune, even though their orbits overlap. Each time they are in the vicinity of a close approach, the resonance keeps them safely separated. Jupiter's moons, Io, Europa, and Ganymede are in a 1-to-2-to-4 resonance. For every orbit Ganymede completes, Europa completes exactly 2, and Io completes exactly 4. This is called the Laplace resonance, named after Pierre-Simon Laplace, who first described it in 1805. The three moons have been locked in this precise gravitational harmony for billions of years. And it is the Laplace resonance that drives the tidal heating we discussed earlier, the gravitational squeezing that keeps Io erupting with volcanoes and keeps Europa's ocean liquid. The mathematical harmony of three moons' orbits is the reason that Io is the most volcanically active world in the solar system, the reason Europa may have life, the reason Ganymede, the largest moon in the solar system, has its own magnetic field. Numbers governing music, governing geology, governing chemistry, governing possibly biology. All of it traceable to mathematical relationships so elegant that when you encounter them, your first instinct is to ask, who arranged this? And the answer, as best as science can determine, is physics did, gravity did, time did, no arranger was needed. The mathematics arranges itself. Here is a mind-blown moment that I have saved for deep in the night, because it requires your mind to be in that soft, open, receptive state that comes just before sleep. There are planets around other stars. We have confirmed thousands of them. As of 2024, more than 5,500 exoplanets have been confirmed, with thousands more candidates awaiting confirmation. Planets are not rare. Planets are abundant. Most stars appear to have planets. Many appear to have multiple planets. Some stars have planets in their habitable zones, the range of distances where liquid water could exist on a planetary surface. Astronomers including Sarah Seeger at MIT and Dimitar Sasalov at Harvard have dedicated their careers to the search for Earth-like exoplanets and the theoretical basis for life on other worlds. Sarah Seeger has written about what she calls the cosmic imperative, the idea that life, given the right conditions, may not be merely possible, but near inevitable. That the chemistry that leads to life on Earth is not exotic or unusual, but rather the natural tendency of carbon chemistry when given energy and liquid water and time. If she is right, and she is careful and rigorous and does not overstate her case, then the universe may be full of life, may have always been full of life, may have been generating life and ending life and generating new life in countless iterations across countless planets in countless star systems for billions of years. Earth may not be the first. Earth may not be the best. Earth may be one of an extraordinary number of living worlds. And if that is true, if the universe is as biologically rich as the chemistry suggests, then life is not the fragile exception. Life is what chemistry does when conditions allow. Life is the universe's tendency, its inclination, the thing it makes when it can. You are not a miracle of impossibility. You are evidence of what the universe naturally does. You are physics expressing itself in its most organized, most experiencing, most wondering form. I told you at the very beginning of this journey that the shocking revelation was that you have never been still, that you are moving through space at extraordinary speed at every moment of your life. Let me add something to that now, after everything we have traveled through together tonight. You are also not alone. You are moving through space at extraordinary speed, surrounded by a solar system of extraordinary variety and beauty, accompanied by Mercury with its 3:2 resonance and its extreme temperatures, by Venus with its runaway greenhouse and its backward rotation, by Mars with its ancient lakes and its blue sunsets and its enormous patient volcano, by Jupiter with its great red spot winding down after centuries and its 95 moons including Europa with its hidden ocean, by Saturn with its temporary rings and its methane sea moon Titan, by Uranus, tipped on its side, named its moons after Shakespeare, by Neptune with its supersonic winds and its backwards orbiting captured moon. This is your solar family. These are the worlds that share your star. These are the bodies that have shaped the solar system into the environment that Earth inhabits. You have never been alone, not for a single second of your life. Let me tell you what happens next, not tomorrow, not next year, but next, in the cosmic sense. The sun, like all stars, is on a known timeline. It formed about 4.6 billion years ago and will remain much as it is today for another approximately 5 billion years. It is a middle-aged star. In stellar terms, it has lived about half its life. For the next 5 billion years, the sun will continue to slowly brighten. This is a consequence of the nuclear fusion in its core. As hydrogen is converted to helium, the helium ash builds up, the core contracts slightly, temperatures rise, and the fusion rate increases slightly. About 1 billion years from now, the sun will be about 10% brighter than today, warm enough that Earth's oceans may begin to slowly evaporate. About 3 to 4 billion years from now, Earth's surface may become uninhabitable for complex life, though microbes may persist longer. In about 5 billion years, the sun will exhaust the hydrogen in its core and begin to swell into a red giant, expanding to perhaps 100 to 200 times its current diameter, possibly engulfing Mercury and Venus, and perhaps even Earth. The outer solar system, Jupiter, Saturn, Uranus, Neptune, the Kuiper Belt, the Oort cloud, will survive. Some of Jupiter's moons may briefly become habitable as the sun warms them. Europa's ocean, long frozen at the surface, may break through. Titan's methane lakes may give way to liquid water as the sun's expanding warmth reaches them. The outer solar system may have its own brief age of habitability as the sun expands and warms what was once the cold dark of the outer system. And then the sun will shed its outer layers in a beautiful nebula, a cloud of glowing gas expanding outward through space, and the remnant core will become a white dwarf. A dense, hot, slowly cooling ember about the size of Earth, with no fusion remaining, just slowly radiating its remaining heat into space. For billions of years after that, the white dwarf will cool, growing dimmer, growing redder, growing darker. In perhaps 10 to 20 trillion years, to 1,000 to 2,000 times the current age of the universe, the white dwarf will cool completely and become a black dwarf, a cold, dark, dense object no longer shining. The first black dwarfs have not yet formed in the universe, because the universe is not old enough for any white dwarf to have cooled completely. They are a future state that no telescope will ever see, but the atoms will still exist. The iron and carbon and oxygen that were once in Earth and the planets will have dispersed, but they will continue. Atoms are remarkably persistent things. Here's the thing about knowing all of this. The 5 billion years of sun left, the eventual red giant, the white dwarf cooling over trillions of years, that I find not frightening, but genuinely calming. 5 billion years is so vast a timescale that it renders every human timescale not just small, but essentially instantaneous. 5 billion years is the kind of number that should produce not anxiety, but release. Whatever happens in your life, in any of our lives, the sun will still be rising tomorrow morning, and the day after, and for 5 billion mornings more. The solar system will be here. Earth, though it changes, will be here. The orbital mechanics will hold. When you feel urgency, when you feel that everything has to be resolved immediately, that there is no time, that you are running out of chances, the cosmos offers you this correction: 5 billion years. The sun is 5 billion years from its next major transition. You have time, not infinite time. No one has infinite time, but you have time. And in that time, there is room for rest. There is room for the kind of quiet that allows something to grow and deepen and become what it is meant to be. I want to tell you something that a planetary geologist named David Grinspoon wrote. Grinspoon, who is a researcher at the Planetary Science Institute and the author of several books on planetary science and astrobiology, has spent his career thinking about the long-term trajectories of worlds, about what makes planets thrive and what makes them fail, about what the history of our solar system tells us about the future. He wrote, and I am paraphrasing carefully here, that our planet is unique in the solar system in this, that it is the only planet we know of where inhabitants have become aware of their planet's situation and have the potential to do something about its future. Earth is not just a passive participant in its own history. Humans, we, are the first species on this planet capable of understanding what the planet is, where it is going, and making choices accordingly. We are the part of Earth that knows, the part that can respond, the part that can, if we choose, take the long view. That is an enormous responsibility, and also an enormous gift. We are the universe waking up on one world in one solar system among hundreds of billions, and asking, for the first time, what do we do now? The planets don't have that question. They simply follow the mathematics, the ellipses, the resonances, the Kepler laws, the gravity. They don't choose. They don't wonder. They don't ask what comes next. We do. And as we approach the final section of our planetary journey tonight, I want you to carry that with you, not as a burden, as a wonder. You are the questioning part of the solar system. You are the part that can look up and ask why, the part that looked at Saturn through a telescope and felt beauty, the part that looked at the pale blue dot and felt smallness and connection at the same time, the part that lies in a bed at night and wonders about the planets. You are the most extraordinary thing in this solar system that we have yet confirmed, and you are about to fall asleep. We have traveled far tonight. From Earth, our blue, magnetically shielded, moon-stabilized, breathtaking home to Venus, the cautionary twin that chose differently. To Mars with its blue sunsets and its ancient lake beds, and the patient enormity of Olympus Mons. To Jupiter, our great gravitational guardian, with its ancient storm winding down and its 95 moons and Europa's hidden ocean. To Saturn with its improbable temporary rings and its Shakespeare-named moons, and Titan with its methane rain and its glassy seas. To Uranus, tipped on its side, cold and strange and quietly magnificent. To Neptune, predicted by mathematics before it was seen, windy beyond imagination, with Triton orbiting backwards in the dark. To the Kuiper Belt, where Pluto waits with its heart-shaped plain and its water-ice mountains, and where Clyde Tombaugh's ashes drift past the world he found. To the Oort cloud, that great invisible sphere of sleeping comets, reaching halfway to the nearest star. And to the edge, where Voyager 1 and Voyager 2 cross into interstellar space, carrying our music and our voices into the dark between the stars. And now, gently, we come home. I want to leave you with one final image, not a dramatic one, a quiet one. Every night, every single night of Earth's long history, the same solar system has been above the sky. Every person who has ever lived, every person who worried as you worry, and loved as you love, and lay awake in the dark as you have, has looked up at some version of this sky. The stars were in different positions. The sky changes over thousands of years as Earth wobbles and moves through the galaxy. But the same sun, the same moon, the same planets have been there, unchanged in their essential nature. The Neanderthals saw Jupiter rise. Ancient Egyptians watched Saturn move slowly across the sky and recorded its position. Galileo pointed his telescope at the moons of Jupiter and changed everything we thought we knew about the universe. Carl Sagan looked at the pale blue dot photograph and felt the weight of it and sat down and wrote. And tonight, you are in that same long line of people looking up. Or, in your case, lying down with the sky in your imagination, which I would argue is even better. Because imagination has no limit. Imagination doesn't need a telescope. Imagination can be anywhere in the solar system, anytime. So let your imagination rest now in whatever part of the solar system calls to you. Maybe you are floating just above Saturn's rings, looking across their impossible flatness towards Saturn itself, vast and golden and striped with clouds, its rings extending in either direction to the horizon and beyond, millions of miles of ice and sunlight, silent and still. Maybe you are at the bottom of Europa's ocean, in the dark, near a hydrothermal vent where warm water rises from the rock and billows gently into the cold. It is quiet there. It has always been quiet there. Whatever lives in that ocean has never known noise. Maybe you are on the surface of Mars at sunset, when the sky turns its characteristic blue-tinged rose, and the sun, smaller than from Earth, but unmistakably the same sun, touches the horizon, and the shadows of the ancient canyon walls grow long, and the wind picks up just slightly, carrying fine red dust across the empty plains. Maybe you are with Voyager, moving silently through the dark, carrying music, carrying music, carrying rain, moving at 34,000 miles per hour away from the sun, away from everything you know, into the vast and patient darkness between the stars. Wherever you are, let it hold you. Let the universe hold you the way it has always held you, at every moment of your life, at every speed and every scale. Let the planets be in their orbits. Let Jupiter stand watch. Let the moon hold Earth steady. Let Saturn's rings catch the light for a few 100 million more years. Let everything be exactly as it is tonight. Scientists named 3 things that you can take from our journey tonight. Jen Oort, who taught us that the solar system extends far beyond what we can see, and that things can be real even before we can directly observe them. That our knowledge is always incomplete, and there is always more, and that incompleteness is not a failure, but an invitation. Carl Sagan, who taught us that the universe does not diminish us, that the scale of the cosmos, properly understood, enlarges us, that we are not made small by the vastness, we are made remarkable, a way for the cosmos to know itself. something in the universe that wonders about the universe. And Caroline Herschel, the 18th century astronomer who catalogued thousands of stars and discovered multiple comets, and who wrote in her personal journals about the experience of looking at the night sky, of finding in that vast, cold, indifferent dark something that felt like home. It can feel like home. The sky can feel like home. The planets can feel like home. Because they are. They are your family, your context, your cosmic neighborhood. They have been there every night of your life, whether you looked or not, whether you knew or not. And they will be there tomorrow night, and the night after. And for 5 billion more. You are on the pale blue dot. You are warm. You are breathing. The solar system is in its proper order. Jupiter is on watch. The moon is steady. The golden record is traveling. And somewhere, perhaps, beneath the ice of Europa, in the dark of an alien ocean, something small and living is doing what life does. Persisting, continuing, being alive. As you are alive. As you will be when you wake up tomorrow, refreshed, your mind having wandered through the solar system and come home again, ready to be here in this extraordinary, brief, unrepeatable, precious, blue-green morning on the only confirmed living world in the known universe.